of vector. I told you that vector is something which has magnitude as well as the direction. Its direction consists of two components or more important, the Cartesian planes we are taking. Okay, suppose if we are taking a vector which lies in 2D or two-dimensional area, so it will have two components. One is along x-axis and other one will be along y-axis. So if we divide our vector into its components, so one component will be along x-axis and other will be along y-axis. You can see in figure 1-8, which represent any vector lying in xy plane as the sum of vector parallel to x-axis and a vector parallel to y-axis. Whenever you will draw a vector in a Cartesian coordinate, it will simply split into its constituent components. If the plane is of x along x and y, then obviously the components which you will achieve will be along x and y. That is ax and ay. If you have y and z, then you will attain the components along y and z. By definition, each component vector lies along a coordinate axis direction. Thus, only a single number is needed to describe each one. Okay, here you can see if it lies in the first quadrant, your vector will be positive. If it lies in the second quadrant, what will happen? The x-axis will become negative, whereas the y component will remain positive. Fine. In case of third vector, in case of third quadrant, both x and y components will be negative. Then here also x will be positive, whereas the y component will be negative. So previously we stopped our lecture on the magnitude, I guess. Okay. If we know the magnitude of A, the vector A and its direction can be calculated. You are very much familiar with this formula that cos theta is equals to ax over ay over A or ax over A. When you are taking x along x-axis, then it will be ax over A, यानी कि x component divided by the magnitude of the vector. जब x axis के along होगा, then we will have cos theta. जब y axis के along होगा, then we will have sin theta. From here we can calculate ax is equals to a cos theta and ay is equals to theta. Okay, at the end, whenever we want to know either the vector we have lies in which component or the coordinate, we will look into the value of ax and ay. If we know the magnitude A of the vector A and its direction given by angle theta, we can calculate the component from the definition. Now see figure 1-9. The component of Bx is negative because its direction is opposite to that of the positive x-axis. See. Now the components which are present in the second coordinates quadrants were negative. The component B of y is positive, but C of x is negative. See, By was positive, but here we are taking another vector, so its x-axis is negative and y-axis is also negative. So what will happen? The negative values will cancel each other's effect. Okay, now we have to find the angle of the resultant vector. Before that, we must know how to calculate the magnitude. You are very much familiar with this formula, which is A. Here, this A is for magnitude. It is not in the bold letter. A is equals to under root ax square plus ay square. Now, from the definition of tangent of angles, you know that tan theta is equals to ay over ax. And if you want to calculate the angle only, what you will do is theta is equals to tan inverse of ay over ax. There is one slight complication here. Suppose if ax is 2m and ay is minus 2m, then tan theta is equals to minus 1. But there are two angles having tangents of minus 1, namely 135 and 315, which is a multiple of 45. So how will we know which of the angle we have to choose? Then what we will do, we will go towards our quadrants and we will check which one is negative and which one is positive. See here, we have x-axis positive and y-axis as negative. Which quadrant will it make? See, we have x-axis as positive and y-axis as negative. So see which quadrant it will. X-axis as positive and y-axis as negative. So we will have this fourth quadrant. To decide which is correct, we must look at the individual components because AX is positive, AY is negative, the angle must be in the four quadrants. So which angle we will have? This 315th angle. Here, till here it is 270. So obviously the angle over here will be 315. So whenever we are determining the angle, we will look into the magnitudes of our x-axis and y-axis, and then we will choose in which quadrant our theta will lie. Same is the case for if you have two vectors and if you have three vectors, this goes on. And yes, when you have two vectors, what you will do in order to calculate the resultant, what you will do is you will add their x coordinates and then you will add the y coordinates in order to make a single resultant. Then it will be easy for you to calculate its theta and its magnitude and so on. If you have more than one values, then you will add more than one x components and more than one y components. Here's a short example. The pilot of a private plane flies 20.0 kilometers in a direction of 60 north of east. Then 30.0 kilometers straight east. Then 10.0 kilometers straight north. How far in what direction is the plane from the starting point? So you have to actually calculate the displacement. The situation in this figure is shown. We have to we have chosen the x-axis along east, y-axis along north. It's up to you either which of the coordinate you choose for what value. Now give them the names. It's A, B, and then C. Obviously, resultant vector will start from origin and end till here. So what we will going to do is we have to find the value of ax and ay along its value along x-axis and along y-axis. For that, we know that it's A, for x-axis it's A cos theta. So the magnitude of A is 20.0. Cos of theta, you know the angle is 60 degree. So cos 60. And for AY, it is A sin theta, the magnitude of A sine of theta. You got these two values. Now to calculate the resultant, we know resultant is equals to ax whole square plus ay whole square divided by, sorry, under root. Putting the values, and then you will get the value of r, and then taking the value of theta, which will be ay over ax with the tan inverse, and you will get this. This is one method. There is another method. For this, you will calculate a resultant vector. Its Rx component will be divided with the cos of theta, and Ry vector will be divided with the sine theta, and then you will get the values along x-axis and along y-axis. This is for the components of a vector. Now we are moving towards our next topic, which is unit vector. Unit, you know, means one. Unity means one. So basically, a vector whose magnitude is one is known as a unit vector. Uh, this vector is, you can say, meaningless. Meaningless in the sense that whenever it is multiplied with anything, it causes no change. So what is its function? It basically provides the direction in the space. It will tell us that either our vector will go along x-axis or along y-axis or along z-axis. They provide us the convenient notation in many expressions involving components of vectors. It will further divide our components. In xy coordinate system, we can define a unit vector I that points in the direction of positive x-axis. If we have a unit vector j, it means we are talking about y-axis. And if we have a unit vector k, then it means we are talking about z-axis. See, this is x component of a vector. I can write it as this ax multiplied with the I unit vector. Okay. Similarly, ay can be written as ay multiplied with the unit vector j. And similarly, if we are talking about any resultant, so instead of writing ax and ay, what we will do, we will simply put these values axi and ayj. This will obviously shows that we are talking about ax and ay. When two vectors A and B are represented in terms of their components, we can express the vector sum using the unit vectors. How we can do that? You know, I have just taken the resultant as AXI plus AYJ, and for B vector, BXI plus BYJ. Now I am taking the resultant of vector A and vector B, which is any other vector C. So what we will do, we will add the x components with x components and y components with y components. See, AXI and BXI. I'm adding and taking the I unit vector out. Now AY plus BY and taking the J unit vector out. Now the sum of AX plus BX will be any other vector, which is CX, and Sum of ay and by will be any other vector cy. With x vector, I will put this unit vector I, and with y resultant vector, I will put this unit vector j. And this goes on. If we have three or more vectors, we will add their x components, then we will add their y components, then we will add their z components, and at the end we will get another resultant vector along with the unit vectors I, j, and k. Now we have products of vectors. There are two types of products in a vector. Product means multiplication. Its multiplication is different from that of the scalar quantities. You cannot only multiply 2 into 3 equals to 6. Here the multiplication comprises of the rules. If there are two values or the two quantities which when multiplied give you a scalar quantity, you will take a dot product. And if you have two quantities and they give you a vector quantity, then we will take a cross product. The definition of scalar product of two vectors a and b means we will get a scalar quantity at the end. And its formula is a dot b equals to ab cos theta. AB means the magnitude of vector A, the magnitude of vector B, and the angle between them. Because of this dot, it is called as the dot product. You can also name it as a scalar product. You can also call it a dot product. It is a scalar quantity, not a vector quantity. Whenever two quantities, two physical quantities have a dot product, they will result a scalar quantity, not a vector quantity. And the quantity can be positive or negative. When theta is between 0 and 90, the value will be positive. When it is between 90 and 180, the value will be negative. And if theta is equals to 90, then the product will be 0. The commutative law holds for scalar product, but it does not hold for vector product. Okay, what if we have the unit vectors along? How will we multiply? It's very simple. You have two vectors, a vector A and a vector B. Splitting it into its components, AXI plus AYJ plus AZK, then B, BXI, BYJ and BZK, and we want to multiply them. So obviously what we will do, we will simply multiply I unit vectors with I unit vectors, J unit vectors with J and K unit vectors with K. बाकी सबका अगर हम multiplication लेते हैं, see if I multiply I with J, then we know that angle between them is 90. So वो obviously at the end it will become 0. So I'm going directly. It will become AX, BX, AY, BY and AZ, BZ. The rest of the values will be cancelled out. Now you are given an example. Here a vector A and a vector B is given. Find the angle between the two vectors. So how can you calculate that? You know you have A dot B is equals to AB cos theta. That was the formula. So just simply deriving the formula in this form, cos theta is equals to AX BX plus AY BY plus AZ BZ divided by AB means the whole magnitude. Now first of all take AX BX AY BY and AZ BZ. putting their magnitudes only. You got this? Now, resultant of A can be calculated as ax square plus ay square plus az square whole under root. Then b bx square, by square, bz square and whole under root. Put the values in the formula and you will get the angle 66.6 degrees Celsius. Sorry. Work is the example for the scalar quantity, which is the dot product of force and displacement. Now we have another product which we called as the cross product or the vector product. It is denoted as A cross B. To define the vector product, we take its notation. So that's why we call it as a cross product. Okay, suppose I am taking a cross product of two vectors which are A and B. So we will get a resultant vector C. Instead of writing A cross B, I'm writing here C. C equals to AB sine theta. This is the formula for the cross product. We measure the angle theta from A towards B and take it always to be between 0 and 180. Equation 1-25 is always positive as the vector magnitude must be. We note that also that when A and B are parallel or anti-parallel, NC is 0, obviously. There are always two directions perpendicular to the given plane. To distinguish between these, we imagine rotating vector A about the perpendicular line. You know this clockwise rule. If I cross J, it will result K. If J cross K, it will result I. And if K cross I, it will result J. If it moves anti-clockwise, then you will get a negative sign. I cross K will be negative J. K cross J will be negative I. J cross I will be negative K. Here the commutative law does not hold. If you reciprocate it, you will get a negative sign. Okay. Now the cross product of two values can be seen like this. Here, if I take I cross I, the angle between two unit vectors will be 0 and sine 0 is 0. So I cross I will be 0. So see, the first value will become 0. Now what it will become? AXI cross BYJ. Here, I and J will give us the unit vector K. Then AX and BZ, I cross K. I cross K will give us a unit vector negative J. So when you further solve it, you will get a resultant as A cross B equals to AY BZ minus AZ BY with I common plus AZ BX minus AX BZ J common and AX BY minus AY BX with K common. So this will be Cx because it has a unit vector I. It will be Cy because it has a unit vector J. And it will be Cz because it has a unit vector K. Its examples are torque, angular momentum, etc., etc. To determine the value, we use right hand rule. It is also called as a cyclic rule. You can also call it a clockwise or an anti-clockwise rule. And then you have an example which I hope you can solve yourself. Just have to determine the angle. Uh, okay, just have to find the vector product. It's easy, you can find. With this, I'm ending my lecture. I hope you understand the points. And if you have any question, you can ask. But